with electric field problems. An electric field is produced. Electric field is produced, which equals 450 newtons per coulomb. 450 newtons per coulomb. West. What force and acceleration will an electron experience? Please remember electron idea here. By the way, go ahead, since I said electron, which direction will this electron go? East. East. This electron will go east. Negative means going the opposite way of the electric field, right? What force and direction will the electron experience? 2. Let's set up another problem. I don't feel like I need to go have you do a blood chug right now. Let's set up another problem, just like the force vectors, adding those. Let's just add some electric field vectors here. I've got in fact, let's do 2 of these problems. I got a positive 4.5 coulomb charge. I have a negative 3.2 coulomb charge. And I want you to find for me up here x. Let's set these up again in a equilateral triangle with the sides of 2.5 meters. I want you to find for me the sum of the electric fields at that point, x, right there, x. Remember, there are 2 possible ways to solve that. You can use the equation that deals with the big charges creating the electric field, right? E equals k big Q over r squared. Get an electric field for each of those, figure out the people with it, add the vectors, right? Get an electric field at that point for each of those 2 individually. Figure out the angle that goes with it. One's positive, positive pushes away, the other's negative, negative pulls towards. Remember that whenever you're trying to figure out these angles. Okay, in other words, this electric field's coming like this, that electric field's coming like that. I expect this resultant to be quadrant 1 or 4. One of those 2 quadrants is the resultant.
How do you know that's positive? It's electric field.
Electric fields go away from positives and comes toward negatives, and it doesn't have to do with another charge then. The electric field exists as if there is no charge. Another way you can do this problem, if this idea freaks you out, another acceptable method would be say, okay, let's put a positive 1 coulomb charge there. Put a positive 1 coulomb charge there. Figure out what the net force on that positive 1 coulomb charge is, and then use the equation E equals F over little q. Solve the force, you know the little charge. That would give you an electric field also. Okay, so you could use either of those methods. I recommend solving for just electric fields directly using E equals K big Q over R squared if you have not been given a charge there. Or, and then run. I would recommend always using positive there. That's most used. Drop in the negative and do with directions yourself manually. You're doing the directions manually by the angles here. Okay? Yeah, I can do that. Right. Morgan.
So big Q would be the 4.5 and the negative 3.2.
Yes, ma'am. Yes, ma'am. Kind of what you're looking at here, just as an idea of this one. You're looking at, let's label these A and B. So you're looking at A E equals K 4.5 over the distance between them was 0.5 meters. Hey, how lucky are we? It's already in meters. You don't have to worry about that. Right? So you get E equals something. Right? Now I got to figure out the angle on that. Positive, right? Going away. Put an XY axis on that. You know, this is 30. That means this is 30. Yeah? Being the angle on this guy, 60 degrees. Then I can come around and explain that a little bit more as you're doing it. Okay. B. E equals K big Q over R squared again. Let's come back at it. Just plug those numbers in. K. 3.2, I'm dropping the negative. I'm going to do it directions myself manually by the angle. That's why I can drop the negative. Okay. Divided by, once again, the same distance, 2.5 squared, so I get E equals something at, now let's get this angle. Now, negative pulls towards, right? Emphasize my XY axis here. If this was 30, this is 60. Negative 60 degrees, if you will, from that x-axis. You're going down below, right? You could call this all the way around to 270 plus 30, 300. 300 is the same thing as negative 60, right? So I'm going to use negative 60 degrees, right? What do you do with two electric fields with angles? Well, you add those vectors. You add those vectors. Another problem that I'd like you to try. And you've seen problems like this. What am I on? 3? Okay. Let's put a negative 5.2 Coulomb guy here and another negative 3.4 Coulomb guy here. All right. They're separated by 5.2 meters. And I want you to solve for me. For the location where the electric field is 0. The location where the electric field is 0. And just guessing about this 5.2, the electric field is going to be stronger. So it's going to have to be closer to the 3.4. So let's say it comes somewhere around here, right? I want you to find where X at, where E, some of the electric fields is going to be 0. Some of the electric fields is going to be 0. This is going to involve a system of equations. This is going to involve a system of equations. I'll set you up on this one also. Let's call him A, him B. So electric field for A is going to be, let's call that little a, little b, if you will. The electric field for A is going to be K negative 5.2, and I can drop that negative, right? I'm going to direction myself, over little a, the distance to that point squared, right? And B, it's going to be E equals K 3.4 over little b squared. Okay? And I'm wanting, yeah, positive 5.2. I got rid of the negative just because I'm doing directions manually myself. And I'm wanting these two. I'm wanting 0 to equal K 5.2 divided by A squared plus K 3.4 divided by B squared. And I'm looking for a distance. Now, K I know, right, that's constant, it's in my packet. But your brain right here is screaming at you, right, oh no, this equation has two unknown variables. How do I do that? Well, you have another relationship between these two. Your other equation would be 5.2 equals A plus B, right? I recommend solving that around for, take your pick, doesn't matter, A or B, down there in that bottom equation. So A would, A is going to equal 5.2 minus B, right? Plug that in for A, and try to solve from there. Where do I get what from? I told you the entire distance between A and B is 5.2. Okay, I told you that entire distance was 5.2. That, yes, good. Thank you for bringing that back up. So that is the critical component here. That is the critical component here. All right. So that's number 3. And we'll pause there. All right. For the recording, that's subtraction, not addition, because the vectors are going opposite ways.
Yeah.